This is an interesting topic to go into. Group policy is a vast thing to discuss, so I've tried to boil it down to the essentials and make my point here. I feel there may be a lot of questions afterwards, and we'll just kind of take it as we go. First, I'll show you an example of why you should never put a temporary picture placeholder somewhere. You run out of time to go change it. So my name is Matt Stone. You can find me on Twitter. I'm Soldo on the Puppet community. I do have some stuff on the Forge for Windows if you ever need help with random things. And you can find me on GitHub as well. So let's talk group policy. Why are we using it? Is it doing what we need it to? Do we understand what it's really doing? And do we know that it's doing what it's really supposed to be doing? So originally, group policy was that original abstraction layer. There's a lot of talk about modeling and abstraction with Puppet, and you'll see a lot of these same things mentioned when we start talking in group policy. The difference being we're talking late 90s, early 2000s here with group policy, where we can take registry changes and object manipulation and wrap that up in something nice and easy as specify the update service location, or we want to change if users can log in locally or not, and be able to flip those bits and change that context. So in a way, with Puppet, you are following this same trend. You do have an abstraction layer where you can just tell it what you want and it can make things happen. But over the course of the talk, we'll kind of go over what some of those differences are and why, in my opinion, moving these kind of things into Puppet is a healthier way to move forward as you start modernizing your infrastructure. What happens when you start bringing DevOps into your organization is you start seeing new patterns and practices for how you're going to manage your infrastructure. You see these things here, like it encourages these consistent and reliable behaviors. It allows us to start moving to express the entirety of our infrastructure as code. We can start being transparent in our processes. One of the best and worst things in moving from ops to doing some sort of development work is git blame. It encourages you to work together, though, and work through those things and start collaborating to actually build this full stack of what you are building and what you are delivering to a customer. So we've been working on this now for about a year at Getty, specifically on the Windows side. We already had, we're about half Linux, half Windows. We had already done about, like the Linux side was fairly covered with Puppet. The Windows side, there were attempts. If anybody's done this for several years on the Windows side, you know just a combination of what was available from a Puppet standpoint and what was available from a Windows 2003 to 2008 standpoint made trying to get that level of automation a little more difficult than you would have liked it to. At Getty, we ran into, or at least I saw a unique problem where if you're in the enterprise, you're bringing DevOps in, you normally see politics as one of the key issues in starting something like this. They had already gone through a transformation. They had already brought in Puppet successfully on a lot of things, and they love technology. There's, Docker, Docker, Docker all the way down, things like that. If there is technology, yes, there's some in production somewhere. We didn't necessarily have the political battles. We had technology battles, which battles being a bad word. It was more about there were many teams that were trying to get a lot of things done at breakneck pace. We needed time to slow down, which is a difficult sell to management. Time to slow down and talk to these people about what they were doing and try to figure out how we could tie all these things together. So we had some goals. We wanted to reduce this complexity. We had tons of technology everywhere, both on the Windows side and on the Linux side. We wanted to figure out a way to integrate all these things together. So we had various cloud provisioners. We had multiple OSs on each side, and man, if I could show you the enterprise architecture diagrams, your head would spin. We wanted to just wrap it all up and build this pipeline that went from a user submitting a request to being able to deliver a server. Wanted to end these, you may have it, you may have solved this already, but you can get to Puppet. When you get to Puppet, everything goes fast and builds and everybody's happy. But somebody may have to enter a ticket and wait 5 days for a server to be built. And we needed to put a stop to that. So we did a little bit of work around the edges and heavily integrated Puppet into the process. And part of that was moving into infrastructure as code, not just on the Linux side, which also already had a good deal of that, but on the Windows side, and to try to hit full coverage on Windows, which gets a little more insane the further down you go. So defining code for us, we wanted it to be text-based, documented, and versioned, for starters. Anybody in this room should be able to read that code, and I don't care if you don't know Python or PowerShell or even JSON for that matter. It's written in a human-readable language that we can commit to Git. We have repositories with version control where we can see where these things are being pushed in. This gives us those qualities we want out of our infrastructure, where we can start modeling changes and performing tests and doing all these things that are the benefits of moving into DevOps practices. The other fun bit is we wanted our code to be data center redundant and, more importantly on the Windows side, start to get domain independent. We had many domains partially from, I guess, fun over years. Let's call it organic growth. There were maybe 15 years of when somebody had an idea to do a new thing in a different space, a new domain grew. If we acquired a company, that domain came in and didn't necessarily get migrated out of and destroyed, it was still there. So if you're in environments that have many domains with many trusts going every which way, and now you're seeing group policy on top of this, you start seeing problems with the inconsistencies across all of these things, where if you have Puppet configuring and you're going this way or that way, and there's group policy in there, you can't be assured that you're going to get the same thing, and you don't have that visibility to see if that's true or not. So we wanted to build our code to say, if we build in Amazon or in VMware or in Azure, if we built in domain A versus domain B, we could get the same build of an application and just rely on using factor and all this additional metadata to start classifying and really putting what was important to us into the configuration of the systems. So the pipeline we ended up putting together here was a little bit of homebrew and a little bit of open source and a little bit of enterprise. We went with Packer to get this sprawl of, if you've worked with VMware, you may have said this, or you may be the person that fights against this, but if you have 50 templates sitting in VMware, and if there's people that say, well, as long as you use my template with my thing and my chain, it works perfectly. We wanted to put an end to that. We wanted, you get Windows 2012 R2, and it's patched, and we build your thing on top of it. And our provisioner, if you need additional hardware, you can say, I need drives configured like X, I need network configured like Y, and we will do that at the provisioner level. But we only want to worry about one template, and we want to automate the patching and updating of that template. So on a monthly or quarterly, or even on like an emergency band, if there's a security outbreak and we just need to get a new template in there, we can do that. And we want to be holistic about this. We're equal opportunity OS nerds here. So the way we treat Linux is the way we treat Windows. We can use Packer, we can use scripting that's native to Windows administration. We're using PowerShell, we're trying not to use batch, but sometimes you just have to. But these are things that anybody that doesn't know DevOps can still contribute to if they know how to work with batch, if they know how to work with PowerShell. They just really need to know JSON. That's the lowest barrier to entry we can give them. And there's enough things through using, say, Visual Studio Code with a JSON linter to make sure that they get things in the right spot. Punch-Out and Phoenix were named from our developer cohort that loves naming things after classic video games. And there's a long string of these things, I can tell you that. Phoenix was the provisioner. This was the thing that made all the magic possible. It's a REST API that can consume the JSON and go out to whatever provisioner or cloud service we need to, build all that, does task chaining. So the final steps of there are connect to Puppet, give it the role that we told it we needed for Puppet, and go and build the rest of the box. Maybe some add-on steps at the end for if we want to run some endpoint verification or if we want to register with the CMDB. We're talking REST APIs here, so we can do really anything we wanted at that point. We did have the problem that you create a REST API and you think you're really clever, but you still have teams that don't talk to REST APIs every day, especially on the Windows side. You have this wide skill set where some people are into PowerShell now, some people are going to click on next until the day they die. And we are really trying to push against that. I think, I said last year when I talked, it was 2007 or 2008 that Microsoft started being really passive aggressive, which is a very Seattle thing I'm learning, to say like, we made this really nice way to script, you should learn it. And they keep pushing that more and more and more. And you see as like server core becomes the option on top of the installer and Nano Server starts coming out, that headless Windows where you're driving commands to this thing is the way to go. If you've dealt with Azure and you see the power of doing things off of like a CLI or using their tooling versus clicking on things, you see the power that they're starting to add to this. They're proving the point that I guess they've learned from past mistakes. And so we ended up with Punch-Out, which was a tool that took it kind of bridged the gap. Their previous method was they had either a ticket where somebody would attach a CSV with or an XLS of what they needed. And the savvier people made that work with Power CLI for VMware. The other people just manually went in and took a couple of days. We just had it turn it into JSON and throw it at the provisioner API, and then we thought we were really clever. So again, the last step connected it to Puppet, and we had a pipeline here. We had infrastructure as code, so we had code expressed at the beginning. We had the actual request come in. If you look at Phoenix there, that's actually an image of the Puppet Enterprise console, and the one fact that dropped there was build info, which was the JSON blob that came out of the request and Punch-Out. So if you ever needed to recreate that box and didn't know how it came to be, you could literally copy and paste that from a factor export as JSON back into the REST API and completely replicate that box down to the IP address. Last step again to Puppet, and once we got to Puppet, we already had everything in code. We could get it going. We had one problem with this, though. Like I said, we were trying to go for everything text-based, versionable. We had this repeatable process here where we could put everything in version control. We could audit these changes. And then we got to GPO. It's not text-based as much as there is text in a console. And you can do XML and HTML exports and play around with it. It doesn't really align with the efforts of everything else you do. We can't really sit that in a Git repository with everything else we've built. And as our development teams are also using Git, we can actually express this pipeline now from how we're building a template from zero to the finish line, except for this one technology silo where people are changing the color of the desktop or affecting how the user logs into the box. We don't know. Could be either or. And there's literally thousands of ways that they can be affecting that box based on the OU, the WMI filter. We don't have the visibility unless we stop everything we're doing, jump into the Windows world, and dive into this. The developers don't have the access to see why their builds are failing if they try to go through our pipeline. So now we're starting to see conflict here from a technology side where we can't actually get to the root cause of the problem. There's just mysteries happening. So we needed to solve these inconsistencies, and we started looking at ways of how can we just remove ourselves from group policy. And that is, well, it's a huge fight. You're first going against, 20 years of Microsoft telling you to use group policy. That's a challenge in its own right, especially if you are bringing DevOps onto a team of MCSEs who have learned to use group policy. There are many ways that we can poke holes in group policy. I'm going to walk through some of them. It's not really configuration management the way we see it today. Back in the day, that's what they could do. This was the best way to get many changes out to boxes where you could touch once and hit many things. And it can apply these changes, but it lacks the full stack capabilities. Now, I have a friend who will always check me on these things. You can go full stack with group policy if you want to write enough scripts with conditional statements to take you all the way to the end of this line. But without all of those things at the end of the line, you're really going to lack that idempotent nature that you get with Puppet, where we can throw this same thing at this box hundreds of times, and we're not going to see any changes unless it needs to enforce the state. And it's one of the bigger things we are trying to drive is we are enforcing state. One of the ways that we can see that with group policy is to, well, go do a GP result. Maybe try running some, there's the PowerShell commandlets where you can go try to do remote validation. But you don't really have this holistic overview natively where we just know the health of our infrastructure. Hey, guess what? The Puppet Enterprise console kind of gave that to us just right out of the bag. When we started moving some policies out into Puppet code, we could see the OS base config, packages, security settings, the app configuration. The little green check, that makes managers really happy. This is a visualization for the people that aren't text-driven, that aren't on that command line all day. They can go here and see what's failed, how many resources are on this box, and when they see resources, if you have one thing to configure them all, you know that's all the things that we care about on that box. We don't care about silos because there aren't any. There is just this one thing with all the resources that we care about. With that, we have, well, now I have to change this slide after the keynote this morning. We can see the failed changes. We can see changes that were made. So we now know if there are security issues with the boxes. We know if new code changes are being pushed out. We have a lot more information right on the surface here than we would ever have jump into single nodes to find out what's happening. Another big thing with this is if you've noticed once you start doing DevOps and getting pretty deep into automating what your current workloads are, you have time for bigger workloads. You start thinking about bigger problems to solve. And for a lot of the people that I've worked with, even if you're the Windows guy or the Linux guy, you start thinking more holistically about your infrastructure. With the console, we're not looking at Windows nodes here unless we drill down specifically to Windows nodes. We are looking at all changes across our infrastructure. And with some of the features in Puppet, when we look at how we're using Hierarchies backends, when we're looking at how Factor is grabbing the metadata for these things, how we use both together to classify, we're not tying things to the OU structures, to their filters, or anything like that anymore. We're not worrying about inheritance or anything like, well, unless you're writing bad Puppet code. We're not worrying about a lot of these common things that come with group policy anymore. We are using this common structure, this common framework for everything that we do, be it Linux, be it Windows, someday network devices, refrigerators, whatever we want to do. So again, the problem being, as it's been the standard for decades, you may have over-relied on it. And if you've ever really dug into a place that's been around forever with their group policy, you'll see a lot of weird things. it's hard to track who the owner or the date of those changes were unless you have some out-of-band change control process. There are some third-party tools you can apply to, I think there's also an advanced group policy thing through Microsoft now where you can do some form of change control and maybe some version control that's still out of band of being able to use Git or anything with your standard workflows. But it's hard to actually get control over what's been done over the years. So whenever I've approached this topic with people that manage group policy, they're first defensive that we can't touch group policy. And after 5 minutes of talking, it usually comes down to the fact that they don't know what it does. They're sure of some of the things. There's some like very valid security policy in there. They know of the things that they've done in there. The things that came before them, if there was some sort of like virus outbreak a few years ago, and so we slammed some sort of antivirus into to drop install in a domain, we're afraid to take that out. We don't know what's going to happen. So you run into this problem where there's potentially 20 years of cruft sitting here getting slammed on every box that comes up in your network, whether you want it to or not, and you need a way to get around that. You don't have that console experience where you're getting this holistic view where you can see all the resources that are being applied to this box. You can't model any changes. You can't actually easily say what would happen if we made this change and get that, I guess, managerial confidence of the green check or the red X. And then the owner of those changes with that abstraction layer, they may have never really seen or understood what objects are being manipulated, what registry keys are being tweaked. Some of that may be available in TechNet libraries. Some of it you just can't find. So the owner might not understand what they're actually doing when they make that change other than they clicked from disabled to enabled. We don't see what happens along that process. So to try to move out of that, we needed strategy, which is not a word. And I was going to change this slide, and I accidentally pushed my finger down too hard on the little MacBook force touch clicky thing. It came up, it was actually a word. So, strategy, it is a word. We needed to undo the non-version, non-commented, not well-discovered configuration management changes that was being made to our infrastructure and that had just organically grown over the years. It's not easy. And unfortunately, I'm not going to blow through the next 20 minutes of here's the solve for every single problem that you have. Part of the problem is Puppet has a very explicit view of your system. It only cares about what you tell it to care about. It also runs as a system account. So some things like the current user context are a little harder to play with. To me, and this has been echoed a couple of times already today, and it's been pretty early day so far, but you have to start questioning how we've been building Windows servers for the last 15 to 20 years. Question that user experience instead of forklifting it into automation. Don't take this 20 years of cruft with you. That is a tip. That's Puppet code on how to fix the user experience for Windows Server. That removes the GUI. Very easy way to lower your attack surface by about 40 to 60%, lower the amount of patches needed. Most things run at it. I highly suggest giving it a shot. Puppet knows how to manage groups fairly easily. Managing that user security policy is a little cumbersome. There's, there are, again, Linux is, you get the trinity. You get package, file, and service can build most things, and Windows gets a little longer-winded than that. There are many other places where things are hiding, and security databases and other things like that are where you definitely start finding places where you want to punch a hole in a wall. So this is a controversial way to put it, but somebody explained to me at length. I thought I would add this bullet. Local users and groups is an option. I've actually seen somebody do the entire company in local users, about 150 users, all locally managed in large manifests. And their reasoning behind this, two, the one I really liked was, if I go to Amazon, I don't have to carry AD with me. Like, good sense. The second is, if we lose everything, I can carry all my users on like a thumb drive and just bring them back up somewhere. That struck me as weird that you could take the company with you on a thumb drive, but it is an option. I mean, you can do it that way. If you pull all the group policy out of AD, you really are left with a really neat LDAP database. And I mean, the key being lightweight was what that was intended for. Local's another way to look at it. So another thing that we had to look at was user rights assignment, essentially setting service accounts. And so I was ashamed to say that you can tweak that with with something out of the Windows 2003 resource kit. There's going to be a lot of these until Windows 2020 or something. But yeah, this is where you start having to leverage where do you make compromises. And there are thoughts of you can make a module that updates group policy alongside of Puppet that just manages when group policy runs. You can make a module that enforces local security policies, but you're still not getting into that code. There's still that abstraction layer that blinds you to what those changes actually are. So for us, we wanted to actually make those changes explicit on the command line, and using this tool allows you to get and set that information for those accounts. Another thing is a lot of people assume group policy automatically means security. And I don't really believe in that because I've seen what some people do with group policy, and that is not security. You should actually be thinking in terms of what your organization needs for security. Compliance is the biggest thing for us. We have some things we need to hit. Other organizations will have other terms of compliance, but you should be building a comprehensive security policy for your servers around what you need to hit and what makes those boxes secure, instead of just flipping bits that say a user has to have a password of X amount of characters. The interesting thing we saw with this is when we extracted it to Puppet, we could go into the we're enterprise customers. You could go into that console and use the node graph. And what you start seeing here is kind of neat from a compliance standpoint, because you can hand in a node graph that shows like all of the security policies that are being applied to a box. And if anything's been modified on those, you can click through, see where the code's been changed. You don't necessarily have that in group policy. We've had situations where people hadn't been able to, they're doing manual process, wouldn't put things in the right OU, just simple mistake. I dragged too far and it landed up in a different OU. They didn't get the right policies applied, and they didn't really validate that ever. So they found things out of compliance by human mistake. This was no mistake. We saw that the right resources were applied, and we knew that we had the right things moving forward. So if you've never actually tried to build security policy, you can do things like, SIS is a good thing to look at. Like, they have hardening guidelines for Windows Server, for SQL, for IIS. You can start there. One of the weirder things is they also point to the group policy contexts instead of telling you specifics. They will tell you in most cases the registry keys, like the parts of the registry where those are in, but not the values to set. So thanks. But there are some situations where as you're doing this, you would find yourself building a test environment, maybe applying the policy to actually diff the registry and find out where these changes are being made. And then documenting the hell out of that and publishing it to the Forge for the rest of us. Windows updates. Puppet actually worked on this, which I was very happy to see. There is a blog post here of someone that was on the community Slack channel that kind of walked through, also talks about how they had to build a module to manage how they were going to do the update cycles. But this is how you can use a module from Puppet Labs that's supported to manage where you're pointing to your internal update servers. Kind of touched on this earlier, but you can run execs to do things like your security policies, your audit policies. Those command line tools are still there in 2016, and they'll probably be there another decade after they get that pushed into code. Definitely start looking at learning how to write modules, extend that into learning types and providers. It's a little bit of a trick at first if you're not used to trying Ruby out. I find most Windows people aren't Ruby people. But Glenn works at Puppet here. He's doing a talk tomorrow, 11:15 to 12, about getting started with modules, if you haven't done that yet. I think he cut short. He was going to talk about types and providers. He'd mentioned that, and might cut that part out. But it's fairly easy. You can look at some of the existing code for Windows types and providers. And the interesting part is now with PowerShell being able to do what it can, between Ruby and PowerShell, you have the ability to get PowerShell to go in, grab all the information you need, export it as a JSON blob to Ruby, get all your parsing done there to do the right actions, and send it back into PowerShell. So it seems very difficult. It's not as difficult as it sounds, but there definitely is a learning curve for that. Other thing we ran into a lot, everybody loves just launching scripts at will out of group policy, setting up login scripts, all that fun stuff. We're interested in desired state, not if a script ran. So we need to know, again, it goes back to that happy green check mark. We need to know if something really happened or not. We also want to be able to use that same metadata that describes the system to configure the system. And most importantly, this drives me insane. Passwords do not belong in plain text files sitting on network shares. No matter how smart you think you are, no matter how many passwords you put on that share, no password should be out in the open. Your password shouldn't be admin. Your password shouldn't be password123 or change me with an exclamation point. There are enough things that exist now between EYAML and Puppet, using Vault, using other techniques. We should be able to scrub all of this from the network entirely. Use Puppet to pull these out of being scripts that just trigger away and make something that's idempotent and that also is going to a secure backend and pulling this information out. I err on the side of over encrypting, even finding links to repositories sometimes, and I'm weird about it. Next, group policy is not package management. Stop doing that. Oh my God. Yeah, so this kind of happens. Sorry, I wrote that before I saw them as a sponsor, but yeah, so we run into these issues, which we started using Chocolatey, and we're aggressively expanding with that. But even before that, you jump on a box, and the first thing you say when you start looking at what's installed is what is all this? Hey, was it automation, group policy, or a human? Why was it installed? What purpose does it serve? Is there a track record? Was there any sort of change control why this was installed? What's the source? Do we have a network share for this? Do we have 20 different network shares? 10? All right, thank you. I'm going to talk real fast going now. So why was this thing put here? We need to know. And can we safely remove it? If there's 4 different redistributables on there, do we know if one of those is going to impact the application or not? So if we can start using Chocolatey, we have a fairly easy way to make package management exist. So the same way we use yum, apt in the Linux world, we can start using it in the Windows world. The Pro version is pretty neat. It gives you other things. Pro doesn't give you resolving dependencies. Chocolatey just gives you that. I made a typo. But you get other things like the ability to have it automatically scan an MSI and try to package that for you. So if you have teams of people that aren't familiar with PowerShell, great way to get them into starting with package management. You can start reducing the complexity. So I've been in places where there's tons of build docs that are like 15 pages of screenshots of what next button to click on and where to type in the server name. This now becomes a package with consistent behaviors. And for me, what makes me the happiest person in the world, we get to package file service. It's not package file, registry objects, rando command line things. We actually can get this parity of what the Linux guys have been doing for way longer. It works really well. So we start seeing a bigger bracket. We're still doing some other things. But you know, it starts making more sense to you. Still Splunk, right? So I guess at the end of the day, you don't need group policy as much as you think you do. It is a scary place to go. But we are at a time in technology where we do have to slow down a little bit and figure out why we've made the choices we've made and start looking towards the modern data center, start looking towards like how automation and these pipelines where we're collaborating with people across the entire company, how this is going to work and why things like group policy don't necessarily click with that. In some cases, you may not be able to dump it just yet. Most importantly with that is if you find yourself in a situation that you're going to be in political fights or you're having Puppet change something every 30 minutes and group policy change it every 90 minutes, collaborate with those teams and be very concrete over what's doing what. If you have group policy teams that manage user policies and that's never going to budge, start with everything else. They get user policies and don't touch them. We can get there. You have a lot of other work to do. There are thousands of choices. So kind of wrapping on that, a couple of years ago, there was a talk as Windows is a first-class citizen, and that gets reiterated a bunch of times about Puppet. You can registry, you can PowerShell, you can install features. That's a little different than what you can do on the Linux side. You find that, anybody use that Puppet Forge app locker module? Yeah, see, that doesn't exist. And that's the problem, is Windows is this, like, everything comes in the box, and that's hundreds of things, much like group policy. And to ask somebody like Puppet to do all of that work is insane. And to ask Microsoft to write all of that code so Puppet can consume it is insane. But DSC came out, and they made Puppet connect to DSC. So Puppet's still winning. 218 modules for Windows in the Forge, 179 known DSC resources right now. But where it gets interesting is a lot of the stuff in the Puppet Forge is focused on these little changes, these little things you're managing, or these utilitarian pieces like PowerShell and the registry. Whereas what you're starting to see in DSC is the subject matter experts that know PowerShell and that know Windows are starting to work on stuff like Exchange and SharePoint and these really bigger concepts. And what I think we're going to start seeing over time is instead of like a huge community of Windows Ruby unicorns popping up, we're going to start seeing people looking inward and starting to pull out those processes from Windows that were very, very difficult to get going into code, and that's going to start becoming DSC resources. So if you've been neglecting spending time with it, probably a good time to get started. You're going to see more and more stuff be supported that way, I think, than you are through the standard Puppet community channels, and more of a healthier way of connecting those two pieces together, and using Puppet more as a strategy piece and a framework for how the data gets into DSC and to how the classifications go through to apply DSC resources in the proper way. So in the future, there's a new world of Windows coming. Like Microsoft has admitted they will now embrace just about anything if you have a Loves Linux sticker. I'm assuming in the next year there'll be Microsoft Linux coming out with SQL Server. We'll see. It'll be crazy again. Containers, like nano server, they don't care about group policy. They don't necessarily care about domain join in the same way that standard Windows servers do. You need to start understanding what this group policy stuff is doing to your systems, and know that when your developer decides he's going to shove SQL into a Docker container and somehow get that past you into prod, it's not going to have those policies applied unless you know how to apply them without group policy. Now is your time to figure that out so you can apply this everywhere you need to. So if you're going to abstract, you need to make this easy to inspect. So if somebody just wants to flip bits, okay. If somebody wants to step into the code and figure out exactly what's going on in the registry or in a WMI object, they can without having to get weird access rights into some hidden command set. But most importantly, just stop dual managing Windows infrastructure. You have a new configuration management tool, and that means you put away the old configuration management tool and you move towards new things. You're modernizing infrastructure. Eventually, you have to sunset the old stuff. So with that, thank you. I have 3 minutes and 54 seconds if anybody has a question.
I guess the one question I would have is if you're going to try to use Puppet instead of group policies, there's a lot of security built into group policies that I could see would be easily defeated using Puppet. Like I could probably, if I have just enough rights on a machine, I could stop the Puppet agent from working, and then I pretty much have control of the machine. Much harder to do with a group policy, because if it's in the domain and it's in the right OU, it's going to get those policies no matter what.
Sorry, I cut you off there, dude.
Yeah, I don't know if you've done penetration testing on this or not, but I could easily see how I could defeat Puppet pretty quickly on a machine with just a limited amount of power on that machine, where I couldn't do the same with group policies.
There are, we've had discussions about this before with things like, do you need to tripwire to see if things are reporting in? Do you need, you do have the console to find out if Puppet hasn't phoned home. You know that the service is no longer running. You need to go inspect and find out what's happening. If you have monitoring, that's a thing. The other truth is, if somebody knows how to get into your system, they can also change permissions on registry keys and prevent group policy from applying. So, right. So I mean, there's ways that you can get at both surfaces. And so we haven't done full, like, hack the hell out of both of these things, but we haven't really seen much of a difference between either other than, yes, you can turn off this thing, but if we're monitoring that it's turned off, we can find out why it's turned off.
Any other questions? Okay, thanks, Matt. Coffee break time.